Okay, coming to the final section on your vectors, we are talking about the application of vectors. Okay, so what you have been encountering so far are simplistic questions as sets in terms of vectors. So real life, okay, vectors is actually activated or used in various things like GPS, satellite imagery, CGI, projectile motion, etc., etc. So what's very likely that you can actually, what you'll be getting in the exams will be probably contextual question or applications question. So most of you will have encountered a few questions by now, be it your revision module or your common test. So again, what we're going to do right now is to run through the steps or processes that you require to handle a contextual question in vectors. So of course, using example 17, the first job is of course to recognize this is actually a vectors question. Thereafter, you need to actually comprehend or understand the story that has been given to you. So in this question, okay, you're given a diagram, you're given two paragraphs of words basically telling you how to interpret the coordinates of the various points given in the diagram. Okay, so spend some time reading through the story given to you and make some sense out of the various position vectors of the various points pertaining to the diagram. Okay, so part 1, you're given a vector. This vector is perpendicular to the flat roof ABGF, and another vector is perpendicular to the flat roof BCHG. You are supposed to find the obtuse angle between the two roofs. Okay, so if you actually look at this question, the end objective is to find the obtuse angle between two roofs. So linking back into your vectors theory, you must actually understand that the roofs actually are representative of planes. So you're actually trying to find the angle between two planes. So read the story again, try to comprehend what you have, and try to strategize and plan your move. Angle between two planes. So before you can find angle, you need the equation for the two planes. Do you actually have the equation of the two planes? So the first plane must be ABGF, and -1 plus 4k is a vector that's perpendicular to this plane. So this is actually the normal vector of the first plane, and similarly this is the normal vector of the second plane, BCHG. Okay, so are you able to write down the equation of the plane ABGF? So you already have the normal vector. Okay, so r dot n is equal to a dot n. So the n is settled. What you need will be a point on the roof ABGF and a point on the roof BCHG. So are you able to read off the position vector of OA and OB, or whichever points that's necessary? Okay, so that will be roughly the context to this question. Okay, so coming back to this question right now, your job is to find the obtuse angle between two planes. Linking back into your earlier chapter, angle between two planes, you need to activate dot product. So dot product of who? Dot product of the two normal vectors. So for part 1, all you need to do is activating your dot product. Normal vector of the first plane, normal vector of the second plane, magnitude of the normal vector, magnitude of the normal vector, take an inverse cos, you get angle of 40.6013. Bear in mind, okay, question say obtuse angle, so do a 180 minus the acute angle, you get your obtuse angle between the two roofs. That's the first part done. Next, you have a humidity sensor to be installed along the line BG, which is 50 meters from B. Your job is to find the coordinates of the location of the sensor. So sensor is on the line BG, okay, and BG happens to be the line of intersection of your two roofs. So the first thing that you need to do now is to actually realize that this is actually an intersection of two planes question. So you need to write down the equation of the first plane first. So r dot n is equals to a dot n. 0, 0, 20 come from? Okay, 0, 0, 20 comes from down here, coordinate of point A and coordinate of point C. Okay, so you can write down the equation of ABGF and BCHG in R dot n form. These are your two planes. Okay, and your job, as I said, is understand that you need to find the intersection of two planes. Use your calculator, activate your GC. You should be able to give me this as your equation of the line of intersection of the two planes. That's the first part done. Then you need to understand the story again. Go back and comprehend the story one more time and re-strategize and see what you need to do. Your job is to find the location of the sensor. The sensor is 50 meters away from B. Okay, the sensor is 50 meters away from B in the line BG. So what you need to understand is this theory. Okay, Y must be 50. How come Y must be 50? Because it is 50 meters away from point B. So in terms of your so-called IJK coordinate, 50 meters away from B means that it got to be lying somewhere here. So the Y coordinate must be 50. So if Y coordinate is 50, can you give me the X coordinate and the Z coordinate? So this is what you're trying to do here. So when Y is equal to 50, you're trying to solve 50 equals to 0 plus lambda from here. This is the Y coordinate. So lambda must be 50. Substitute in lambda to be 50. You can get the rest of the coordinate, the X coordinate and the Y coordinate. And this will give you the exact coordinate of the sensor that you're trying to find. Okay, so part 2 settled. Coming to part 3. This is the one that's most difficult to understand. Okay, so you need constant reference to the diagram, constant reference to the story, and strategize your move. So you have a metal cable which is anchored to the ground outside the farm in front of OABCD. Okay, so where is OABCD? Okay, OABCD is right exactly here, the front. Okay, this is where the front is, and then your anchor is supposed to be anchored to the ground outside the farm. So your anchor is supposed to be somewhere here outside the farm. Then at a point 25 meters away from O, okay, and along OD. (25 meters away from O along OD), so it got to be 25 meters from here, and then 10 meters in front of OD, and then 10 meters in front of your OD itself. So this is roughly where your anchor is supposed to be located. The cable is attached to a point on AB. So where is AB? AB is somewhere here. Okay, and to secure the roof ABGF, we need to find the length of the shortest cable. So understand the story here with reference to the diagram. You will roughly understand that you need to find the shortest distance from this point to the line AB. This is what you need. So this question in vectors, vectors concept will be the shortest distance from a point down to a line. Okay, so go and find all the necessary information required to find this shortest distance. Okay, so you need to give me where the cable is supposed to be anchored. So remember, we say that it is supposed to be 25 meters away from O in the direction OD. So I direction 25 and 10 meters in front of D, so of OD. So if this is point origin, 10 meters in front will be minus 10, 0. This is where your cable is supposed to be located. So this is where the anchor is supposed to be, and we call it the point P. Then you're supposed to find the perpendicular distance of point P to the line AB. Do you have the equation of the line AB? Okay, you have the coordinates of OA, you have the coordinates OB, you can find the direction AB. Okay, and then activating your cross product formula, you actually can find the shortest distance from your point down to your line AB. Okay, spend some time analyzing this solution. Okay, it's not something that's very easy to understand immediately. You need to think before you can understand everything that's happening. And finally, the last part, state an assumption for the above calculation to be valid. Okay, so this is a bit of common sense. Okay, you must understand that the thickness material used for the building is negligible, because if thickness comes into play, your various position factor will change, because your roof is no longer one flat piece. There's a thickness involved. The various coordinates are going to be different. So this is part 4. It's not something that we can really teach. It's something like more commonsensical. Okay, we'll come to the end of the vectors chapter. So all in all, you have 6 massive chapters for this entire topic on vectors. You need to spend some time going through everything, and in particular, I would recommend you trying the self-practice questions in vectors 6, because there are quite a number of contextual questions inside there. You have the likelihood of the likely questions that you will actually get in the actual A levels. Okay, so do not be in a hurry to try everything. Okay, just go through things bit by bit. For example, okay, a proposed strategy is you try 1 or 2 questions every 1-2 days. Okay, slowly build up your foundation so that you can gather the skills in the long run. Okay, take note, it's not something that will come to you immediately. You need to spend some time, spend some effort to gather your skills, gather the confidence to handle vectors contextual questions.